Hello, my name is Valerie Truong, and this is my demo for a VR project that I've been working on, highlighting the cybersecurity concerns in biometric tracking. The main purpose of this project is to demonstrate how virtual reality applications can collect and analyze behavioral biometric data without users fully understanding how much information is actually being gathered. Many people, when they think of biometric data, they think of fingerprints or facial recognition. However, in VR, biometric tracking can also include behavioral information such as head movement, gaze direction, controller movement, and spatial behavior. Modern VR headsets continuously collect this information in order to provide more immersive experiences. For this project, I used Unity and a Meta Quest 3 headset in order to create a simple VR environment that demonstrates how attention tracking works, as well as how seemingly harmless behavioral data can also reveal information about a user. When the experience begins, the user is placed inside a simple house environment with a living room and a kitchen. The user can freely look around and explore different objects throughout the scene. However, unknown to the user who is simply exploring the environment, this VR application is actually tracking all their behavioral data and movement in the background. To keep this demo as simple and concise as possible, I decided to focus on head gaze tracking and spatial tracking. First, head gaze tracking. Unfortunately, since the MetaQuest 3 does not include built-in eye tracking, I instead approximated the user gaze using the forward direction of the headset. So in every frame, a white ray is projected outward from the user's head position in order to estimate where the user is focused on. For trackable objects, I decided to focus on only 3 objects: a painting of a sunset, a refrigerator, and a coffee table. Ideally, if I had more time to fully develop this project, I would have made all the objects trackable, but for simplicity, I decided to only keep it down to 3. Now, as I look around the environment, the system is recording attention duration and view counts for each object as displayed on the Unity console. Whenever this ray intersects with a trackable object, the application records which object is being viewed and how long the user is focusing on it. Additionally, this project includes an attention heat map system. As an object receives more attention, its color gradually gets warmer. This visually represents how much attention the user has given that specific object. Notice that the more time I spend looking at this particular object, the more it stands out compared to other objects in the environment. In addition to attention tracking, I also implemented zone tracking throughout the entire environment that's tracking your spatial movement and location. The house is divided into 2 separate zones, a living room zone and a kitchen zone. Whenever the player enters one of these areas, the system records how much time is spent there. This demonstrates that VR applications can collect not only what users look at, but also where they spend their time within a virtual environment. Now I will press the track button in order to analyze the collected data. The results panel displays several types of behavioral information. First, it shows how many seconds each object was viewed. Second, it shows the number of times each object was viewed. And third, it identifies what the most viewed object was. Next, the system generates a simple behavioral profile based on the object that received the most attention. For example, if the painting received the highest amount of attention, the application may infer that you have an interest in art or visual design. While this behavioral profile is very simple, it demonstrates how raw behavioral data can be transformed into assumptions and conclusions about a user without them even knowing. The results also display movement analysis using the zone tracking system. This data shows how much time was spent in the kitchen versus the living room. Thus, even though no personal information was explicitly provided by the user, the application is still able to build a profile based entirely on their behavioral observations. A major topic in cybersecurity is privacy and data protection. Most users are aware when they enter passwords or upload personal information. However, users are often unaware of how much behavioral information is collected automatically. This project demonstrates silent background tracking. The user is simply exploring a VR environment, but the application is continuously gathering that data and can reveal interests, habits, and behavioral patterns. Another cybersecurity concern is behavioral profiling. Organizations can use this behavioral data to build detailed profiles in order to use for advertising, analytics, personalization, and other purposes. Over time, these profiles can become surprisingly accurate. A second concern is biometric identification. Research has shown that users may be identifiable through their movement patterns alone. Even without fingerprints or facial recognition, the way a person moves and interacts in VR may act as a biometric identifier. This creates significant privacy risks because behavioral biometrics are difficult to change if they are exposed or compromised. This project also emphasizes the confidentiality concerns from biometric tracking. In this demo, data is stored locally for demonstration purposes. However, if a real application transmitted this information to remote servers or stored it where the data could potentially be accessed by unauthorized parties or potential threat actors, it'd definitely be a breach of personal security. The project highlights the importance of transparency and informed consent. Users should clearly understand what data is being collected, how it is stored, as well as how it may be used. Overall, this project demonstrates that even basic VR tech can reveal meaningful information about users. No eye-tracking hardware, facial recognition, or advanced biometric sensors were required. The system only used headset direction, object interactions, and movement within the environment. Despite these limitations, the application was still able to determine what attracted the user's attention, how long they focused on different objects, how often they returned to these objects, and which areas of the environment they spent the most time in. As virtual reality continues expanding into gaming, education, healthcare, and workplace environments, protecting behavioral biometric data will become more and more important. Thank you for watching.